Hello, everyone. This is Working with DBAs in a DevOps World. Thank you, Chris, for the introduction. Let me first start with a little bit about me. My name is Silvia Botros, like he just said, and I'm on Twitter as DB Smasher. I am currently a principal DBA at Sengrit. I've been with the company for a little over 6 years, and I accidentally became a DBA. For any of you who attended my morning talk, I am sorry this part is repetitive. I became a DBA before I joined Sengrit by accident. I was a junior software engineer in a long-forgotten CDN. I was in charge of some Python code that did stats aggregation and billing. And one day, it didn't work as well. 2 days later, I am still knee-deep in my SQL documentation, and the rest, as they say, is history. Let me tell you a bit about Sengrit. We are an email infrastructure provider. Our customers are companies who send millions and billions of emails a day, and they want to make sure these emails get to the inbox, and they don't want to have to deal with all the infrastructure involved with getting all those emails out there. Let me show you some stats about how much scale we work with. We have more than 63,000 paying customers in over 100 countries. We process over 40 billion emails per month. And these are just some of our customers who happen to be household names. Another cool stat that I found out recently is that we send emails to more than half of the unique email addresses in the world just within the last 12 months. So in the journey of getting to that large scale, we learned a few lessons. Let's first talk about DevOps. What is DevOps? It's containers. Is it config management? Maybe it's orchestration. Maybe it's orchestrating containers. No, it's NoSQL, isn't it? A very well-established academic source called Wikipedia defines it as unifying operations and engineering teams under one umbrella. And it kind of makes it sound like this. All you have to do is just get those ops people and those engineering people in the same room and get them to have meetings together. That's how you fix this. So let me start with a bit of a story, and I'm sure this will sound familiar to a lot of people in the room. A big feature. Product decides they want this big feature happening. It's needed in the product. They've been to a bunch of conferences just like this one, and everybody is asking for this feature. So they come back from the conference and they tell the engineering team, we need this feature. The engineering team sits down, writes a bunch of stories in their favorite bug tracker, which is hopefully not a board on a wall. They start assigning points. This is where it gets kind of cool. Some teams use doc sizes, sometimes teams use t-shirt sizes. Anyway, they decide on some sort of size metric for these stories. The really cool team do poker at this point. They go write some code, the sprint goes by, maybe a couple of sprints go by, and that code is written. Then they start testing in something. Sometimes it's testing on their laptops. If they're slightly extra cool, they'll test on maybe like a couple of instances that look a little bit like production, sort of. Or maybe they're testing in Docker, but they're not running in Docker in production, who knows? And then they deploy it to production. And then, yeah, yay, happy? Sure. Nope. So that works the first few times, but next thing you know, they're gonna deploy one feature like that, and this looks like reality. This starts happening more and more often. Your engineers are now getting scared of deploys. It's like a hot potato. No, you deploy. No, you deploy. Because everybody is deploying and they're like, oh God, what's going to go on fire this time? So, and the engineers are not entirely sure why this is happening. This used to be easy, right? We need a DBA. We keep tripping on the database changes. So we need to find someone who's going to make those changes for us so that it's going to be their problem. The database is slow. Last time we had a database change that was urgent, the CTO jumped in and did it and forgot the update clause, and we had to go, forgot the where clause on the update statement, and we had to go find the backups. That is so not a true story. So we need the DBA, so we hire a DBA. They start taking over the database changes. They're the ones who approve every single change that has to happen to the schema. And very slowly, they start looking like this guy. That red stapler is the database. Nobody touch that thing, or he's going to burn the house down. How is your DevOps Narnia now? Some might say, but hey, we did test this code. Like, we didn't just run it and throw it out in production. But what exactly did you test? Did you test with 1 user? Did you test with 10 users? Did you throw like a little more than 10 users at it? Did you do any load testing? Did you vary the load? Did you measure some changes between peak load and average? And how does your system recover from peak load? Did you do any load testing at all? Do you know what is your peak achievable load? Do you know at what point does the system start going sideways and does this feature just completely fall apart and is unusable? Did you make any assumptions about the database? Does your application have explicit expectations as to when queries will come back? What if you multiply that expectation by 2 and now your queries are taking twice as long? What does your application do? What if those queries take 10 times as long? Do you have a way of finding out what happens there, or is it going to be, maybe it will work? The most important question here, are you actually scared of your product succeeding? If I told you this feature that the team has worked on for the last 2 sprints is going to go out tomorrow, and it's going to make hacker news, do you get excited? Or does it get you in a cold sweat? Because you know it's going to be a fire. Yeah, totally broke that a little bit. It's terrible. You're scared to deploy things. You're scared to change things. Sometimes things break before you even touch them. This doesn't have to be this way. Your product is growing. This is supposed to be a good thing. Your company is succeeding. This is supposed to be a good thing. Meanwhile, while all this is happening in engineering, your sales team is rocking it. They're just selling like crazy because everybody wants this product that you just built. So it sounds like a really sad story, I know. But I'm not here to tell you just sad stories. I'm hoping to help you figure out some ways to fix this problem. Here are some steps you can take. First thing you need to do is develop a technology catalog. Everybody sits down and you start writing down all the different techs that you have in your stack. And you do this for multiple reasons. Number one is you need to figure out why each of these are in use. Is it because we wanted caching and so we decided Redis was the best thing out there right now, or we needed a relational database and the most thing we're familiar with is MySQL? Or is it we're using this brand new thing that just came out in NoSQL because Joe, who just joined the team, was in a conference and attended the conference talk about it and decided we should use it for something? You have to have valid reasons that relate to the business as to why you're using every part of your technology stack. Because adding something new to your tech stack has a cost, and it's not going to be just a cost for the engineering team using that thing, but for everybody. The ops team has to learn about it. You have to figure out how to monitor it. You have to figure out what metrics you need to read on of it. You need to figure out how you're going to tune it. So you got to know why you're using any given tool. And I know that may sound like, well, that means you can't use anything that's new, or you have to only use MySQL, and everything has to go in MySQL. That's not exactly true. And boring in quotes, because everybody keeps thinking that relational databases are old, it doesn't mean it won't be challenging. The difference here is that you want the challenge to be, we have so much more traffic, we are growing the business so fast, and that's challenging. Not we got this brand new database that just released, that just went 0.9 last week, and the challenge is that it's new and nobody knows how to use it yet. So you got to pick your challenges, and the challenges have to be for the business growth and not for just the hell of it. Otherwise, you're going to find yourself in that place. Nobody wants to be in that place. Now, this doesn't mean that whatever you sit down and write down as your stack at this point is going to be it for the rest of your life. That's not necessarily true. Products evolve. Customers will ask for new things, and a lot of times they will ask for something that your current tech stack does not support. For example, MySQL is not a good key value store. Maybe you don't have a key value store in your stack yet. Maybe this is the time to figure out one. But you have to be careful with what you're adding to your tech stack. You have to make a checklist, something that everybody can use to make decisions as to whether I can make the case for adding this new piece of software to our toolbox or not. Part of it also is all the training that has to go, so you have to make the case for spending that kind of time. Because the most important asset in engineering org is not actually the licensing costs or anything like that. It is the engineering time. That is the most expensive asset in engineering org. So here are things that you might want to put on that checklist when you're starting to decide whether you need to add something new or work with what you have at hand. Does this new thing support multi-data center? If you're in the cloud, does it support multi-region? If you're adding a new database, and it's going to be part of a product that you promise to be multi-region, but this data store does not, how are you going to work around that? What kind of complexity are you going to have to build in-house to make up for that? What kind of data is going in that data store? Context is everything. So if this is a new billing stack that you're writing for your company, and you decide that we don't want to use MySQL because it has certain limitations, but you want to use this brand new NoSQL data store, now you have to go tell your finance team that the Jepsen test of that database says that if there's a network partition and there's latency of like 10 milliseconds between the nodes, 30% of the data is gone. I'm sure your finance team would love that. So some parts of your product are going to have higher tolerance for risk-taking than others. And so you have to be very aware of that when you're making the decision of what to use to build this new thing. Like I said, if the data has a direct correlation to your company's finances and revenue, you're going to have to be much more careful with it. And you have to really be honest about this last one. Can you really not use something that's already in-house? Now, no database is perfect. They all have their warts. But you got to know which one is okay. So if it's something that, say like MySQL, and it's not very good at availability because it's single writer, maybe you're okay with that. Maybe you'll work around that with Kafka or with some other, distributed log. There's some ways to work around things where you don't have to introduce a completely new data store, for example, to figure out what you're going to do. This is a really good quote by Jean Gall, and it's important to keep in mind because we always wonder at some point, like, why did the system get so complex? Nothing starts out this complex. It starts out as working, but then our needs change, or the customer needs change. So the goal here is not to eliminate complexity and to keep things simple. The goal is to make things only as complex as necessary. So any new piece of software you add, if it's bringing complexity that you could live without, that's complexity you don't need. The next thing you need to do when you're planning this brand new feature is before you write any code involving that new feature, you need to write down how you're going to solve this problem. This is what we call blueprints or architecture design documentation. You need to write in it in full detail. What is the problem you're solving? Why is it a problem for the business? How are you going to solve it? And what are the limitations and compromises you're going to make? And that's the important part. There is no solution that's going to be perfect. So from day one, you need to be clear as to what the solution you are offering to the business is going to actually compromise on. If you're going to say it's perfect, it solves all the problems, then there's probably something not right there. This is the kind of document that needs to involve way more stakeholders than the engineers. Depending on the context of what you're building, it might need involvement from finance. Maybe it involves a lot of hardware or a lot of EC2 expansion. So now your ops team needs to know and your finance team needs to know. Maybe this new feature is going to collect personally identifiable data that you didn't collect before. In that case, probably InfoSec and your audit team needs to know. If you have customers in Europe, you're going to definitely want to keep an eye on that. Maybe it's a feature that you know product is going to want to bill separately. So now you have to involve your billing team and your finance team in advance because they're going to need to plan ahead. Everybody forgets the ETL team. And next thing you know, they're surprised that there's this new feature that they need to track. So this is the point where you need to involve a lot of stakeholders. And guess what? This is where you involve your DBA. Yes. Even if you don't have a new database that you're adding in there, this new feature might involve a change in access pattern to the existing data stores you have, and the DBA might need a heads up on that. This is all the different stakeholders that you might have. Now, the rule is, in general, for human communication, is that in the absence of information, we will make things up. A lot of times, people will not realize that they need to know about something. There will be presumptions made. What you want to avoid as much as possible at this stage is not writing things down or not involving stakeholders, because at that point, InfoSec is going to assume that you're going to redact data for GDPR, for example. If they don't actually get to see the blueprints and get to see that it's missing that requirement, they won't get a chance to say, hey, you're missing this big business requirement, and we have customers in Europe who are not going to like that. So the most important thing to avoid at this point is what we call design by water cooler, designing this new feature by just talking to people and not writing things down. Because that is a very quick way to have mismatched expectations and then disappointment all around. So how do you actually broadcast these things? Do you email it out? Nobody reads email. I think that's a known thing by now. Inboxes are overfilled. Nobody looks at email. So how do you get everybody in the same room to actually discuss this? You do an architecture review. Architecture reviews are when the blueprint is written and everybody who's going to write this code has this feeling that it's close to complete. Everybody sits down and starts reading that document and actually discussing any compromises or any questions they may have on it. Who needs to be in your architecture review? The people building this feature. Not necessarily all of them, because that could be a lot of people, but maybe one or two of the most senior engineers on the team, because they're going to need to be the ones answering questions when people read this document and say, hey, what happens when this part breaks? Those who are looking to learn, architecture reviews are actually a very good way to train up engineers who are still on the junior level. They will get to watch how the senior engineers solve problems, and they'll get to quickly learn that their job is going to be way more about solving problems than writing code, which is super important to teach everybody in the organization early on. Anybody who cares. This is going to be an ad hoc thing where, depending on what the blueprint is and what the feature that everybody's building is, you might want to invite someone from InfoSec. You might want to invite someone from your ETL team. This will be their chance to come in and bring their feedback. The most important thing about architecture review is that it is not some sort of technical smackdown where everybody's trying to prove they're right. The shared goal in these discussions needs to be the business value, getting this new feature out and getting the customer something they need, getting the business the growth they need with taking as little risk as possible. And that does mean compromises sometimes. This is a really cool quote from Charity Majors. We always worry about experiences being silos, like the DBA knows about certain things that are completely different than the engineers, that are completely different than the InfoSec team. Architecture reviews are a very good way to change those quote-unquote silos into an actual shared power. Everybody's sitting down, bringing their perspective, and they get to walk in each other's shoes through these discussions and come to a better understanding of how to make this thing work better. DevOps may sound like it's only about ops and dev, but the idea is for it to just be the seed. If you are going forward with the whole DevOps thing, you want it to actually include way more than just the ops people and the dev people. You want it to include DBAs. You want it to include your finance team. You want it to include your InfoSec. So at this point, The engineering team wrote a bunch of code, and they wrote a bunch of tests. The blueprint got approved. We think we did the right thing here. We're ready to deploy to production, and it'll work, right? We did architecture review. Everybody looked at it, and it seems fine. Nope. You got to do fire drills. This is the kind of thing that will probably apply more for larger features, larger releases, maybe large rewrites. But you got to do this. Fire drills is when everybody writes down some failure scenarios, and then they write down what they think will happen when these specific pieces fail, and then they go do it. And they get to watch whether their expectations were met or something else entirely broke. This is also a cross-functional thing. You can't do fire drills with just the engineers, because in reality, once this is in front of the customers, if it does catch on fire, it's not going to be just the engineers. They're probably going to have to pull in some ops people. They're probably going to pull in the DBA, the network engineers. And so the fire drills need to be treated just as dealing with production outages. Company called Stripe calls them game days, which they've written about extensively and done some conference talks on, and it's really interesting to watch them do this in action. They need to be well documented. You need these things to not just be disseminated using tribal knowledge and just drinking conversations. When you come back to those later and you're trying to determine what improvements you need to make, these documents are going to be very important. And they need to be published internally. Maybe not everybody that has a stake in this feature is going to be useful during the fire drill, but they may want to read about how it went later so they can bring input to, hey, that kind of breakage was actually super critical for us. Maybe we need to have a bug fix for this. So you need to always disseminate information through documents. It's much better to work down the line. The next thing that can cause issues in DevOps land is tech debt. Now, it is unrealistic to expect that you will never have tech debt. If you don't have any tech debt, then you are probably not churning out enough features and your company is not going to last very long. But there's a difference between taking a known risk and taking a completely unknown risk. What you're trying to do here is to be deliberate about it, kind of treat it like loans. So one thing that I mentioned, for example, like this morning, maybe at the beginning of the business, you're going to use an ORM to deal with your database access, because it's easy, because it's already part of the web stack, so everybody can just plug into that. Is it going to work all the time? Probably not. If your business does well, and a couple of years down the line, you are dealing with 3 or 4 times the number of customers, and you're starting to see peak queries on the order of 10, 15,000 queries a second, an ORM in Python or Ruby is probably not going to handle it very well. So unless you are aware from day one that at some point in the future, given some sort of milestone of success, you need to start working towards ripping out the ORM, getting something like Proxy SQL or even one of the paid libraries out there, and get that into place so you can scale out your data store, it will still be a thing that's needed, but it's going to be a surprise, and you don't want that to be a surprise. And tech debt is not just in code. The worst tech debt I've seen has been in databases, and it's the hardest to control, because once it's in place, it's really hard to clean up. Another thing that I've talked about before is people always forget timestamps on table. Next thing, the tables are terabytes big, and they can't figure out how to get data out of it, because now your critical database is in the terabytes of size. It's important to keep an eye on these things. If you're making a shortcut in your schema design early on, you need to be very deliberate about what is that shortcut, how long is it going to last, and what is the milestone at which we need to rewrite this thing. It's a great drug, those databases. This is obviously a symptom of success, which is a good thing. The important thing is whether you have planned for it in advance or it was just completely new and everybody thought things were going to work for forever. There's only so much you can do adding indexes in databases, so you have to be careful that at some point you're going to have to make decisions whether you start splitting your data horizontally and write tooling around it, or you start, taking out data and, building a warehouse maybe. And it does feel like you're changing your wheels on a train that's running at 100 miles per hour. Now, some may say, but we are running on the cloud. Everybody right now runs in Amazon. We'll just stick an auto-scaling group on top of that Cassandra cluster, and it will just work. I've seen some smiles, so clearly some people here tried this. So, no, it's not going to work all the time, because here's the thing. Amazon has limits. They will not let your bad engineering behavior cause problems for the rest of their customers. So it doesn't matter if you get to avoid pixie booting hosts locally, or like if you get to put auto-scaling groups in place. The cloud gives you convenience. It does not give you an exit code from like caring about things. So you can do cloud. It's still not going to help any bad engineering behavior that you might take a shortcut with early on. And this is an important thing. This is not just an engineering concern. It's super important early on to get your product managers involved. Remember that DBA Milton at the beginning? Now, one of the reasons he ended up like that is because nobody was listening. And so he'd come and tell in the next roadmap meeting that maybe we should rewrite this particular part of the code because our user settings are getting too inefficient in the database. But nobody's got time for that. And so the roadmap moves on with new things. Nobody in the product side understands the scaling problems, and they'll very quickly learn the harsh lesson of why they can't have new features, because everybody is scared to add any new features because we're not scaling very well. And a big part of this is going to be we didn't involve the DBA when the product team was figuring out what this feature list is going to look like. Remember an important thing. Stability is a feature. And it's a feature that needs to involve everybody in the company. So it's on the engineering team to be honest to the outside parts of the engineering org, to the product and to the business, that when there's a problem, they make it clear there's a problem and it needs to get on the feature list of improvements. Improvements for scale is not a luxury. It is something that you have to do if you are to succeed as a business. Finally, you don't need to hire a DBA to do all these things. I started this talk off by saying that it's about working with DBAs, but hey, here's a little secret. Sometimes the DBA is you. If you attended my morning talk, it's about how you can be an accidental DBA and be a MySQL guru. Sometimes the DBA just happens to be one of the engineers. If nobody owns it, everybody owns it. Or I guess if everybody owns it, nobody owns it. So at some point, it's going to be a problem. And even if you don't have a DBA on staff, this is going to be a thing that you're going to have to fix. So learning these behaviors early on, whether or not you hire a dedicated DBA later, is going to be a thing that you need. And that is all. If anybody has any questions.
All right.